We discovered the problem of using fixed sizes in the previous video. Here we see the products have a fixed width in pixels, which will not fit onto this preview device, which is an iPhone 8. Pixels do have their place, and there are lots of good use cases for them. But when working with responsive layouts, we want to use a different unit of measure, which is more flexible. i.e., we want the size to be able to stretch when there is more space, or shrink on smaller screen devices. This is where relative or scalable units come into play. If we go over to our style.css and just scroll up a little to our image, which you can see here, we've already taken a little look at these already when we set this image width to be 50%. Here the image will shrink or stretch to 50% of the available space, rather than being a fixed size like the products. We can also use percentage for other elements too, starting with the body. So let's scroll up to the body section at the top of the page. Currently we have this set to 1000 pixels. The value is up to you, but now if we set this to be 80% and give that a save, we can now go over to the browser and refresh. Let's close these down. And now if we make the browser even smaller, we can see that the content by these lines on the outside here is always 80% of the browser width. Also, there are relative sizes which can be based on the viewport. The viewport is a user's visible area of the screen. We can target the viewport width with VW or the viewport height with VH. So if we wanted 50% or half of the screen width, it would be 50 VW. So let's add this in the body, save that, refresh, and now this takes up half the width of the user's viewport. Or for 80%, we could change this back to 80 VW, and then save that. And now we have the same effect as 80%. The same goes for the height too. If we wanted the header to be 50% of the available viewport height, we'd do it just like this. So the header and the footer, we can add the height to be 50 VH, reload, and now this header takes up half the available height. I'm just going to remove this because it looks a little bit silly, so remove that from the header section. Other popular relative units include M and Rem, especially for font sizing. To see this in action, I'm going to set the base font size in the HTML at the very top to be 16 pixels. So font size 16 pixels. This value of 16 pixels is often the browser default anyway, but we know for sure by setting it here. Then I'm going to set the font size to be different for the main section. So scroll down to the main selector and also add the font size into here. And let's say 12 pixels for this example. If we go over to the browser and refresh, we now see the products have a smaller font size of 12 pixels, and then all the rest are set to be 16 pixels. There is nothing here on the screen which is unexpected. We see the text size all looks the same except for the smaller font in its main section. Now let's change the font size for the products using the M unit of measure. So let's go down to the product and down at the bottom. Let's set the font size this time to be 1M. If we save and then go over to the browser and refresh, we don't see any changes on the screen. This is because M relates to the parent font size, which is the main section. So basically 1M is 1 times the size it would normally be, which keeps it at 12 pixels. We can confirm this if we open up the developer tools. And then if we toggle the device toolbar back to the desktop size, and then if we select one of our div sections, so div with the class of product, and then lift this up a little bit. If we then open up this computed tab on the right hand side and then scroll down, We can see here, if we look for the font size, so look at the font size here, that it's set to be 12 pixels. Therefore, if we go over to our CSS and change this to be 2ms, this will be twice as big as it would normally be. So refresh, scroll down to the font size, and now we'll have a value of 24 pixels. We could keep going above 2 if we wanted to, but we're now going to take a look at rem. So this is the m value. So this is based on the parent container. So basically setting this to 2ms is twice the size of the 12 pixels container for the main section. So now let's take a look at rem. Rather than the size being based on the parent, like m, rem is based on the root font size. The root font size is this HTML value of 16 pixels in the top section. So back to our products, rather than setting this to be 1m, so just here we can set this to be 1rem, which is rem. Back over to the developer tools, we can see straight away that this text is the same size as the sidebar. And if we scroll down to the font size in the computed section, this font size is now 16 pixels rather than the 12 pixels we've seen before. We can also scale this up to be larger or smaller. For example, if we wanted it to be 3 times the size of the root element, we could set this to be 3rem, refresh, and now the font size is really big, just like you can see here, and its computed size is 48 pixels. So let's close this down. And just to recap, if we set the font size to be m, this is based on the element's parent. So the element's parent for the product is the main section here. If we would set this to be rem, just like we just seen, this is based on the root HTML element. So in our case, 16 pixels. So great, I'm going to now remove the sections that we just added in. So we're going to remove the 16 pixel root element down to the main section. We can remove the 12 pixels value here. And then finally for the product, we can also remove this line. Now we'll have a better idea of scalable or relative units. Now let's put this into practice with our project. In the next video, we'll apply these relative units to our project, and this will allow our website to be more fluid as the screen size changes.